Okay, this is going to be lesson 2 for sequences and series. Today we're going to talk about series. Okay, so a series means, what that means is you're adding up your terms. So you're actually getting some kind of number answer. It's not a term. Okay, now just like before, you want to find whether it's arithmetic or geometric first. So this is plus 12. This is plus 12, so that isn't arithmetic. Okay, the formula for arithmetic series is this. Sort of looks like the explicit formula. It looks very similar. Okay, all right. So when they say S15, they're finding the sum of the first 15 terms. So it's 15 over 2. All right, 2. This should be times. Sorry. Times A1, which is 9, plus 15 minus 1. Just like before, that's a 12, okay? All right, so what you want to do is make sure you put parentheses around that. Put parentheses around your fraction when you calculate it. Okay, so I got 15 divided by 2, parentheses 2 times 9, plus parentheses 15 minus 1, parentheses around 12, and then close it on the outside. Okay, so you got to make sure you put a parentheses there and then a parentheses outside the 12. So that's going to be 1395. That is going to be the sum if you added all those up. Okay, now the difference here is 8. Difference here is 16. So that means it's not arithmetic. It has potential to be geometric. So 16 divided by 8 would be 2. So 8 times 2 is 16 times 2 is 32. Okay, now the geometric formula says Sn is A1. 1 minus r to the nth power, all over 1 minus r, okay? So in this case, they want us to find the 11th term, okay? So S11, first term is 8, 1 minus 2 to the 11th power, all over 1 minus 2. Now the way I would do this is I would do the numerator first, 8 times 1 minus 2 to the 11th power, close your parentheses, okay? Then divided by, and I would divide by the bottom, 1 minus 2, okay? I would put parentheses around that. That's my recommendation, okay? All right, that's 16,376. That would be considered the sum, okay? Now, this one is subtraction of, wait a second, that's not right. That should be 6. Hold on, that should be, yeah, that's right. All right, this is minus 6, okay? All right. Okay, minus 6, minus 6. All right, so I would use the arithmetic one. So I'm doing S27. So 27 over 2, okay? 2 times 95 plus 27 minus 1. Now my difference now is negative 6, okay? Not positive 6, so I got to make sure I do that. So I can put parentheses around the 27 divided by 2, okay? 2 times 95 plus, all right, 27 minus 1. Negative 6. All right, and that gives me 459 if you were to add up all those terms, okay? Now this one, difference to this is 100. Difference to this is, 200, 100. So second divided by first. As a fraction, that'd be 1/2, and that's what I'm multiplying by, all right? So what I got is, I'm going to use S13. So I got 400 times 1 minus 1/2. All right, to the 13th power, all over 1 minus 1/2. Okay, and I'm going to put parentheses around that fraction. So 400, 1 minus parentheses, 1 divided by 2, close the parentheses, to the 13th power, close it, okay? So I got to put that, all right, divided by 1 minus 1/2. Double close, okay? All right? I get 799.9. Okay, all right. So that's going to be my answer on that. All right. So you guys can go ahead, try these, figure out whether it's arithmetic or geometric first. Okay. Now let's talk about sigma notation. The concept behind sigma notation is this is my starting value. All right, so I'm going to start substituting in here. I'm going to show you how this works by hand, but I'm also going to show you how you do it in the calculator, okay? So what this means is 3 times 1 plus 7, so that's 3 plus 7, which is 10, okay? Then I go to 2, and I substitute 2 in there. 3 times 2 plus 7, that'd be 6, plus 7 would be 13, okay? Then I go to 3, okay? Same concept, okay? And what I'm doing along the way is I'm adding these together. So 3 times 3 is 9, plus 7 is 16. Then I would go to 4. 3 times 4 is 12, plus 7 is 19. And then I go to 5. Now 5, if you notice, that's the top number. So this is the stop number. So I put 5 in there, that's going to be 22. And then you would add all those numbers up. All right, 10 plus 13 plus 16 plus 19 plus 22. And it gives you 80, okay? Now, there's also a way in the calculator that you can figure out the sum, okay? All right, and here's how you do that. You go to Option, Calc, and then you scroll, okay? So Option, Calc, and then you scroll over and find the little E thing. Now, when you select that, what you want to put is what your equation is, okay? The letter that you're using, your start number, and your stop number. All right? So for like this one, I'm going to go ahead and use X, okay? Even though it's an N, it just makes it easier. So 3X plus 7, comma, I'm using X, comma, my start number is 1, comma, my end number is 5. And it tells me 80. So there's 2 ways basically to get the same problem, okay? All right, so if you wanted to substitute, the concept is I'm substituting in there. I'm going to go 4, 5, 6, 7, 8, and then finish at 9. Now, I'm just going to speed this along, and I'm going to go E, okay, X squared, okay, plus 5X, comma, I'm using X, comma, I'm using 3, comma, I'm finishing with 9. So that's 490. And that's how you do those problems, okay? This one, same deal. I'm taking 2, then I'm taking 3, then 4, then 5, finishing with 6. This one I'm doing 4, then 5, then 6, then 7, then 8, then 9, finishing with 10, okay? Now let's talk about how you would type this one in. I would do E, okay, 3 parentheses, 4 parentheses. Now, I'm going to do exponent. When you do an exponent, and this is what you have to make note of, you got to put parentheses around this or it's not going to calculate correctly. All right, comma, I'm using X, comma, I'm starting with 2, comma, I'm finishing with 6. And that's 4,092. Okay, so let's do this one. All right, E, I got 10. Okay, all right, parentheses. Okay, I got 1/3, so 1 divided by 3. Exponent. Okay, I've got parentheses X minus 1, comma X, comma 4 is the start, comma 10 is the finish. Okay, all right, and that's going to be, as soon as it's a fraction, okay, in a fraction, nope, it's going to be 0.555. Okay, all right, and that's the answer for that question. Okay, all right, you guys can go ahead and start with those. All right. Now, since given the series, write the sigma notation. Now, here's what you have to do. Okay, same deal. You got to figure out if it's arithmetic or geo. Okay, you're going to write the explicit. Okay, you're going to simplify that explicit as much as you can. Okay, make it easy. Make your start number 1, and then whatever term they want you to find up there. Okay, so this is a difference of 7, so that is a arithmetic. Okay, this is how I find the explicit formula for arithmetic, all right, sequences. Okay, so what I got is a 3 plus and minus n minus 1 times 7. Now all I got to do is distribute that. That's 3 plus 7n minus 7. If I combine the like terms, that's 7n minus 4. So when I make the sigma notation, I'm going to start with n is 1, okay? And this is going to be 7n minus 4. And I am going to find the sum of the first 20 terms, okay? And you can see if I put 1 in there, 7 times 1 is 7 minus 4 would be 3. If I put 2 in there, it'd be 10, and so on and so forth, okay? This one, difference here is minus 10, all right? Difference here is, actually I don't think that's right, hold on. Negative 4 minus 10. Negative 4, sorry, plus 10. That should be 6, sorry. This is not right. 6, 16, 26. So what I'm doing here is I'm adding 6 as I go, okay? All right, so I got, this is an arithmetic, so I'm adding 10, etc., okay? All right, adding 10, all right? So what I would want to do, use that same formula. I got negative 14 plus n minus 1 times positive 10, okay? I'm distributing that, so that's negative 14 plus 10n minus 1. So that's going to be 10n, sorry, minus 10. It'll be 10n minus 24, okay? So in my sigma notation, I got n equals 1. I got 10n minus 24. And my stopping term here is, I forget, let's say it's S27, or 22, let's put that, it's 22, okay? All right, that's what you do for that, all right? This is S10. Now, obviously, we see this is not arithmetic, it's going to be geo. So 200 divided by 800 would be 1/4, okay? The geometric explicit formula is this, okay? So my A1 is 800 times 1/4 to the n minus 1. So I don't have to simplify it all, the geometric. I can just leave it like it is. So that's n equals 1, okay? 800, 1/4 to the n minus 1, and I finish it at 10 terms, okay? All right, so basically you're just distributing and you work on that, all right? So here are the problems. That top one, I would like you to go to S52, all right? Okay, find the sum of the infinite series, describe whether it converges or diverges. Now, there is a formula, okay, for finding the sum of an infinite series. That basically is this, okay, is A1 over 1 minus R. Now, you want to be able to put parentheses around that. The idea behind an infinite series and the concept is this. That is going on forever. In order for that to be a convergent series, that rate or ratio has to be less than 1. And what that means is that one works. If the R is greater than or equal to 1, okay, that's going to diverge. Why is that the case? Let's say I've got 2, 6, 18. If I added these numbers up going on forever, they just keep getting bigger and bigger and bigger and bigger and bigger. I would not have an actual answer. But if you look at, let's say I had really simple 4, 2, 1, 0.5, 0.25. You see the number gets smaller and smaller and smaller. And that's the concept of a limit, is when you take the limit as it goes on forever in the positive direction, it's going to get smaller and smaller. It's going to approach a certain amount, or converge. Converge is like limit. It's approaching an actual number. Where if it's bigger than that, it's just going to keep getting bigger, and that's what divergent means. So the first step in this is you got to figure out that whether your R, okay, is less than 1. Okay? All right, now this one, 50 divided by 250, would end up being 1/5. So I am in good shape. Okay? So I got 250 divided by 1 minus 1/5. And that's how you have to basically do that. 250 divided by 1 minus 1/5. Okay, that is 312.5. Okay, now this one, okay, all right, 9, I do second divided by this, it's going to be 4. Now, since this R is bigger than that, I would just write divergent. All right, or you could write no solution. It's not going to have a sum. It's just going to keep getting bigger and bigger. You shouldn't calculate it. Okay, if you calculate it, sure, you're going to get an answer, but it's not going to actually be correct. The premise behind that is that the R is less than 1. Okay, so this obviously there's a gap there. That's 500 divided by 1,000. Okay, so 500 divided by 1,000 is 1/2. Okay, so that means I can do that because that's less than 1. So I got 1,000 divided by 1 minus 1/2. All right, I can come up with an answer now. 100, or 1,000 divided by 1 minus 1/2. And I get 2,000 for my answer. Okay, all right. And you can see like that's quickly just sort of decreasing. Okay, so go ahead and find those. Okay, question number 9. Or sorry, the next slide, number 9. We have an infinite series. Now, what you have to do is look at this part here. This is your R. That R has got to be less than 1 for a convergent series. Okay? If it doesn't, if it's not, it's divergent. Okay? If it is, you can calculate it. Okay? You can do this a number of different ways. You could use the sigma and put this in. 8 parentheses 1/2 to the x minus 1. Notice I have parentheses around that, comma x, comma 1. Now, someone's going to say, Mr. Evans, what do we do for infinity? Well, why don't you just use 100? Because the idea is, going on forever, it would eventually calculate to 16. If you wanted to, you could put in 1 here, okay? You could do 8 times 1/2 to the 1 minus 1. That would give you the first term. That would give you your A1, which is 8. All right, and you would do 8 over 1 minus 1/2. Okay, and if you notice, that ends up being the same problem. And it ends up being both 16. So 2 ways to look at that. So that's convergent, and it gets you an answer of 16. This one, if I look inside here, is bigger than that. This is a divergent series. Okay, can't do that one. This one I can do. Okay, that's okay. All right, you can do it a couple different ways. You can use the E thing and do 60 parentheses 1 divided by 3 exponent parentheses x divided minus 1. Okay, comma where x is 1 and we're going to infinity, so I'm just going to use 100. All right, it's going to be 90. Or you could substitute that in and do 60 1/3 to the 1 minus 1, because that's the first term. Whoops, sorry, 60 parentheses 1 divided by 3 exponent 1 minus 1. That's 60, okay, divided by 1 minus 1/3. You can do it that way if you wanted to. Either way is fine. It's 90, okay? So this is a convergent series with an answer of 90. This is a divergent series, no solution. Same thing here, I'm looking there, it's divergent. All right, and no solution. You're not gonna have one, no solution. No sum is probably a better word of saying that. Okay, no sum. Why? Because it's gonna diverge, it's gonna keep going on forever. All right? So go ahead and pause your video, go ahead and work on those. Okay, you gotta think yourself on that last one. Okay, all right. So basically today we talked about how to find the sum. Series means addition. Okay, all right, you're adding those terms up. You can do that with the formula or you can do that with sigma notation.